they feel the same about you, I'm sure. All right, what do we do? This is a good question. Right, yeah, so how do you do it? Factor tree, okay, what is the factor tree with this? So what? We're getting closer.
2 and 27.
No, it's not 2 and 27. Oh, yeah, 2 and 27 work. Thank you. 2 and 27. All right, 27 goes to, I think 9 and 6 is the one we wanted there. All right, what's that do for you? One group of 3 threes, right? Yeah, okay, good. And that comes to the outside as a 3.
And the x is already 3 x's, so it can be left out.
Okay, so then we got a 3x.
And then
Yeah, put y, and then
it's y
and
squared.
Okay, well, don't forget about the
Cube.
2.
Oh, yeah.
That's what I was
So
thinking.
2.
y squared.
Boom.
Boom.
That's
How's that?
good. Let's
So
do
you
another one.
can't do the model.
Can we even do it? Why?
Yeah, because it's an odd number.
Not because it's odd. Don't get mixed up with negatives and that. What is it? Index is the same, so we can do it. Okay, good. So we are multiplying here, so what?
Multiply 3 times 2.
All right, so you multiply the outside numbers, so you get 6.
And then the index stays the same.
Index stays the same.
And 192.
12 times 9, okay, so 192.
And then y squared.
X squared, yeah, don't forget about right, x squared.
Yeah, squared.
Okay, y to the 7. Is that okay with everybody?
Yeah, that's perfect.
Is that, yeah, now you got to simplify it. Thank you. So how do we go about simplifying?
Break down.
192 breaks down into what?
12 and 4, 16.
All right, that's what's nice about it, right? They're right there.
Shouldn't you then multiply before you multiply?
All right, so you can, yes, probably easier because the numbers will become smaller. But for this is just to remember what's going on. Yeah. So
4 and 3.
because you could have simplified to 16, okay, and you could also have done the y's also. But just for this, let's just ease back into it. 4 and 3.
2 and 2. 4 and 4 and 2 and 2.
All right. Now what?
You got 2 groups of 3.
All right, so there's 1, and there's 2.
Outside.
Okay, so then it's 6 times
2, 12.
times another 2, right? Because we had 2 groups, right? And then what about anything else?
You can take out 2 y's.
2 y's, anything else?
No.
Okay, so then the cube root of,
X squared. No, you gotta get the 3.
yeah, don't forget about when you do that. So, yeah, right, so then the 3 x squared y. Is that okay?
Yeah.
Is that done? Can we leave it that way?
Yeah, you can leave that way or still.
Yeah, so either way I'm fine with, right? Because this is correct. If you wanted to, 24 y squared cube root 3x squared y. Right, that's something more like you take home to mom, Is that okay?
Yeah.
All right, you guys are killing it. I like it.
That's not good.
Okay. Can we even do it?
Yeah.
Because index is the same. Okay, so there's another way you can think of this if you would like. You could say this is the same as this. And maybe this helps and maybe it doesn't. But it's worth to at least understand that this is the same. Does that make things better?
That's how I put them.
Why is... Well, okay, so maybe you don't like the way it looks. I don't know. But there is a harder way to go about this and an easier way to go about it. And I do think that this way is the easier way to think about it to make sure that you don't make a problem harder.
It's all under the same.
So what does that do for you?
Let you know the index is the same.
Well, okay, well that's true. Why is this? The hard way to do it is what Dylan said before. Okay, because we don't need to do that if there's no radical left in the denominator. And so this way, I think, kind of tells you that you want to simplify something first.
You can already divide.
So then, if you divide right away,
It's 11
square root of 11,
x squared.
x to the what? Squared, right? You got 3 up top. There's 1 down, this is 1 down here, right? So you do subtract them. That's it. Is that done then?
Yes. Because it's y equals 12.
But it's not quite done because of the x's in there.
The x on the outside. And then 11.
Is that okay?
Yeah.
Can we even mess with this problem?
Yeah.
Because the indexes are the same. Again, if you want to, you can think of it like this, if this helps you. But in this case, can we simplify 5 over 3?
No.
What about x over y? Yeah, they're not like, like bases. Okay, so why is it not done?
Because you can't, have a radical in the denominator.
Right, so you have this situation right here with the radical in the denominator, which is bad. Okay, so what does that mean that we have to do? This is what Dylan was talking about before.
3y squared.
That's close.
3 squared y squared.
Cube root of 3
Squared
squared
y squared.
y squared. Why are these things squared? Why is it 3 squared and y squared?
Because you already have 1 and you need 3 squared. It's the same as index.
It needs to be the same as the index, right? We already had 1, 3, so we had to get 2 more to get 3 of them. We already had 1 y, so we needed 2 more to get 3 of them. And then we have to do that to the top as well. Oh boy, that's like plastic surgery gone bad. All right. What happens to the numerator? Or let's do the denominator first. What happens to the denominator?
Turns into 3y.
3y, good. What about the numerator?
You have to multiply by the same.
So it's a cube root of,
3.
yeah, it's a 3 squared. I know it looks like,
3 stays inside, right? It's
well, we can't simplify it right now for sure.
15.
Well, do your order of operations the right way
But
though.
it was squared. So it's 3 squared, 5. 3 squared.
So 5 times 9, right? So 45. Is that okay? Can we simplify? What can we simplify? All right, so he wants a 45 divided by 3. Is that, can you do that?
Yeah.
Why can you not do that though?
Because it's inside the radical.
Yeah, right. So this one's inside, this one's outside. They don't mix together. Okay? It's just like this y here can't cancel with these because this is inside and this is outside. Is that okay? How many people feel pretty good about all of those?
I feel pretty good.
All right, 2 people. Good job. All right, here we go. First one. What's the answer to the first one?
5. 5. 4. Well, you said 5. Sorry, I'm looking at the first one.
First one. I heard one answer that was correct.
X plus.
Oh, I've heard 2. No. The answer is x plus y. Why? You cannot add terms that are not like terms, and these are not like terms because they are different variables. Is that okay? All right. What about this one?
2x.
2x. You're not multiplying, is right. 2x. Is that okay? Right, this is a 1x plus another x, and then you got 2 of them, 2 x's. Is that okay? All right, what about this one? Right, we had 4 x's, we had 3 more x's, and now we got 7 x's. How does that make you feel? All right. Okay. So what is the answer to the first one? 5 cubed, no.
Cube root of 5.
Cube root of 5, no.
Five.
Square root of 5, no. It's already simplified. This is the answer. Good, yes. Why?
You can't simplify that.
Okay, well, so, okay, that both of those are true. Yeah, I mean they're both prime numbers,
There's no square root. Well, there is, but no like.
so you can't simplify them. But this is just like x plus y, right? These are not like terms. They're not the same, so you can't combine them. Is that okay? Oh, this. All right. Yeah. Can you do this one? No. Why? The indexes are different. So then this would be. It's just the same. Is that okay?
Yeah.
Just like term stuff. Okay. All right. Oh yeah, you can do these. You can do these. We're not multiplying. We're not multiplying. Huh? We're doing the top one. Top one first. Top one first. Wait a minute. What was x plus x?
2x.
So what does it?
2, 3.
2 square root of 3.
Okay.
Is that okay? Now there's 1. This is 1 radical 3 plus 1 radical 3. They're the same, which makes us happy. And so then you just say, well, now we have 2 radical 3s. Yeah. So you got one hand and then another hand. Yeah. 2 hands. So what is this one? Is that okay?
Yeah.
That's not too big. Right, the 4th root of 9 is probably 1 point something. Is that okay? All right. Seven
2.
cube root of 2. Is that okay?
So just treat that like it's an x.
That's right. So, right, big difference between adding and subtracting and multiplying and dividing. And just in general terms, you can multiply and divide any numbers there are, period. Adding and subtracting, they do have to be like terms, and this still, you still want to treat this like he just said, like these are just x's. Or if they were different, like an x and a y, where you can't combine them at all. Is that okay with everybody? All right.